Welcome to Next Minds Academy daily classes. We do offer subject tutoring in the subjects physics, maths, chemistry, physics, and biology. All you need to access our lessons are the following down here. You need a smartphone, Wi-Fi, data, you need Zoom Cloud app, and then email address, and you need earphones. So we always provide the ID and password for all our lessons. You can WhatsApp us at this number here that you're seeing on your screens in case you want to book any lessons with us. I also have a website which is www.nextmindsacademy.com. So visit it and register with us, book lessons with us. You can also utilize the notes which are there. You can also visit us on YouTube, Mr. Academia, and enjoy all our lessons. Subscribe to it such that you enjoy the full package of our lessons. So for today, we are going to look at X-rays. X-rays, these are short wavelength electromagnetic waves which are produced when cathode rays are stopped by a heavy metal. So among the properties of cathode rays that we looked at when we are introducing cathode rays, we said they produce X-rays when they hit or when they strike matter. So that's why in the definition of X-rays, we define them as short wavelength electromagnetic waves which are produced when cathode rays are stopped by heavy metal. So they are electromagnetic. This is very important. So you'll find when looking at the electromagnetic spectrum, you'll find X-rays among them, and they'll be having properties of all electromagnetic waves. So meaning that X-rays can also be reflected, refracted. They can be, they show all the properties of electromagnetic waves. They will also be traveling at the speed of light. So in the production of X-rays, we basically use an X-ray tube, which is here, which you can see in our diagram. So in the X-ray tube, basically, a low voltage is connected to the cathode, filament cathode. Here is connected to a low voltage. So when the low voltage is connected to a filament cathode here, it heats the cathode. So the cathode is heated by a low voltage, and when it is heated, electrons are produced thermoionically. We looked at what we called thermoionic emission, and we said it is the production of electrons as a result of heat. When a substance is heated and it produces electrons, that process is what we call thermoionic emission. So the electrons which are produced, this focusing cap here, it focuses the electrons and directs them towards the target. So the focusing cap directs electrons towards the cathode. So between the cathode and the anode, because this is the anode this side, between the cathode and the anode, there is connected what we call high voltage. So you can see it is connected in between the cathode and the anode. So this high voltage here, its use is to accelerate the electrons as they leave the anode being focused by the cap. They are accelerated by this high voltage which is connected between the anode and the cathode. So when electrons are accelerated, we have cathode rays, because cathode rays are streams of fast moving electrons. So inside this tube here, there is no air, meaning that there is a vacuum, or it is evacuated. You can see the glass tube is evacuated. So we evacuate, or we remove the air to avoid the collision. Remember, if there is air, there will be that collision between air and the fast moving electrons, which can reduce the speed of electrons. So when the cathode rays strike the tungsten target, so we use tungsten. Generally, we use tungsten because tungsten has a high melting point. So these cathode rays are moving at a high speed. So when they hit this target, a lot of heat is given up. So heat is given up. Actually, 99% is heat, then 1% is X-rays. So we use tungsten because it has a high melting point. Since a lot of heat is produced when cathode rays, which are fast moving, hit the target, so we need to use a metal with a high melting point. So that's why we also connect the cooling fins. So these ones, they are used to cool down the anode, because when fast moving electrons hit the target, 99% of the kinetic energy that they come with is converted to heat, and then the 1% is what is converted to X-rays. X-rays. So we produce X-rays finally in that order. So that is what each of these parts here does. Of course, the lead shield, since X-rays may be harmful depending on whether they are soft or hard, so we need lead shields to protect from the effect of the X-rays. So the mode of operation, we've explained all this in what we've talked about. Everything here has been properly explained to us. So the following are the energy changes which take place since the process starts from here. So meaning that the first, we have electrical energy that is supplied here. So when the electrical energy is supplied, of course, there is a heater here which heats the cathode. So meaning that electrical energy is converted to heat. And then the heat, this voltage here accelerates the electrons which are produced thermoionically. So meaning that the heat energy is then converted to kinetic energy due to the accelerating cathode rays or electrons. And when they hit the target, there is heat which is produced and X-rays. So in the energy changes, that's why we have electrical energy being converted to heat energy, then kinetic energy, and finally electromagnetic energy plus heat. So the electromagnetic energy is from the X-rays which are produced. So you can either say heat plus X-rays. So these are the energy changes that occur when actually that occur in an X-ray tube or in the production of X-rays. The intensity of X-rays depends, or it is highly determined by this part here, which we've called the low voltage. So we have two parts, the low voltage and the high voltage up here. So the intensity, that is the strength of the X-rays, it is determined by the low voltage. So meaning that when we apply a higher voltage or a higher filament current at the low voltage part there, the X-rays will have a high intensity than when we apply a low voltage. Then the penetration power is the one which is determined by the high voltage, which is up there. So for it, it varies the penetrating power because it increases the kinetic energy, or it increases or accelerates the speed of the electrons. So when the electrons are moving at a higher speed, a very high speed, their penetrating power is too high. And when they are moving at a lower speed, their penetration power is low. So that leads us to what we call the types of X-rays. So X-rays are of two types. We have what we call soft X-rays and what we call the hard X-rays. So soft X-rays, for them, they are produced by use of a low potential difference. So among their properties, they are produced by low voltages, they have low penetration power, they have low energy, the wavelength is long, of course, and then they are used in X-ray photography for human bodies because of their low penetration power and to avoid damaging some of the body organs. Then hard X-rays, for them, they are produced by use of a high potential difference. That is at the position of a low voltage. If we put a high potential difference, we get X-rays. So some of the properties is that they are produced by high voltages. The penetration power, of course, is high. Then they have high energy, the short wavelength here, and then they are used in the destruction of cancerous cells. So we had not looked at the properties of X-rays, but the properties are here. They carry no charge at all. They are neither negative nor positive. They are not deflected by magnetic and electric fields. They can penetrate matter, though the penetration depends on what type of, are they hard or soft? They cause ionization of gases. They affect the photographic paper. They travel in straight lines and at the speed of light. Since they are electromagnetic, it also means they can be diffracted, refracted, and reflected. They have short wavelength. They cause fluorescence, and they produce photoelectric emissions. So some of the uses of X-rays include the following. For the medical uses, they are used to investigate fractures or what we call broken bones in X-ray photography. They can be used to treat cancerous cells or what we call malignant growth in the human body. Detection of complicated body organs. I think this is similar to malignant growth. Then they're also used to detect tuberculosis in the lungs and also diagnose stomach ulcers. In industries, detecting cracks or what we call flaws in pipes and metal castings, we use X-rays also to study the nature of crystals, what we call crystallography. In motor tires, they are also used to detect faults, and also in paints, they are used to detect defects in paints. Paints, the thickness of paint, basically use X-rays. So X-rays, much as they are useful, they can also be dangerous. So some of the dangers is that they destroy living cells in the body, and they can also damage blood cells and eyesight. So it's not advisable to get that overexposure to X-rays. They can cause genetic mutations in the body, and they can also cause burns, deep-seated burns, due to their greater penetration power, especially when you use hard X-rays. So that's why it's advisable to use the soft X-rays, especially when doing diagnosis of the human body. Then the safety precautions, these are to protect us from the effects of X-rays. The first one is we should avoid unnecessary exposure. Actually, I think they advise like once in 6 months, so avoid overexposure to X-rays. Always use protective clothing, or what you can call thick lead shields, or protective clothing made of thick lead. Keep always a distance between the X-ray source, and always use soft X-rays when you're diagnosing human tissues, because the hard ones can damage the body cells. Okay, thank you.